So have you ever wondered how we actually get from a chatbot that just, politely answers your questions to an autonomous system that actually gets things done? I mean, we are standing at a literally fascinating turning point in technology right now. We're moving away from AI that just spits out text to AI that actively acts in the physical and digital world. But how does that whole process actually work under the hood?
Welcome to this explainer. Today, our mission is super clear. We are going to completely unpack the core mechanics of agentic AI. We're basically going to deconstruct the anatomy of an AI agent by looking at its three fundamental components. Think of them as the brain, the vault, and the hands. By the time we're done looking at these pieces, you are going to see exactly how modern AI is achieving actual autonomy.
Okay, let's dive right into this. Here is our roadmap. First, what is agentic AI? Second, planning and reasoning. Third, memory and statefulness. Fourth, action and tool use. And fifth, we'll wrap up with the security reality.
What is agentic AI? Let's define autonomy.
Okay, take a look at this quote from the classic textbook, Artificial Intelligence, A Modern Approach. It basically defines an intelligent agent as something that acts appropriately for its goals, is super flexible when the environment changes, learns from past experience, and, well, makes smart choices. Now, you might be thinking, isn't this old news? And you're right, this isn't a net new concept in computer science. It's actually been around for decades. But what has absolutely revolutionized this space, what's making it spread like wildfire right now, is the massive, sudden leap in large language models, or LLMs. These models are now acting as the raw reasoning engine, which allows these agents to actually fulfill this academic definition at a completely unprecedented, staggering scale.
Moving on to part 2, planning and reasoning. This is the brain.
For an agent to actually be autonomous, it can't just react. It needs to formulate, track, and constantly update its action plans. This requires what we call a chain of thought, or COT. It's basically a step-by-step sequential reasoning process. Instead of just blurting out the very first answer that comes to mind, the agent's internal logic breaks a really complex problem down into logical steps. It formulates a plan, applies sequential logic, and then executes a step. It often uses a pattern known in the industry as reason plus act, or REACT for short. This is absolutely crucial because it allows for these dynamic multi-step workflows that don't even require a human in the loop. And as you'll see, this builds into some incredibly sophisticated reasoning strategies. Honestly, it's a lot like having a completely ruthless built-in editor. To manage really complex tasks, the agent uses reflection. That's where it iteratively evaluates its own past actions so it can adjust its future behavior. It also acts as a self-critic. It essentially double-checks its own work, aggressively critiquing its output to catch and fix errors before it even moves to the next step. And for those absolutely monumental goals, it uses something called sub-goal decomposition. Actually, a better way to think of that is just dividing a massive, impossible-looking task into bite-sized, manageable milestones. This is the AI's brain at work in real time, constantly analyzing, pivoting, and adjusting.
Part 3. Memory and statefulness. Welcome to the vault.
Now, what's really interesting about this slide is how it highlights a major limitation we used to have. Standard LLMs, they kind of have the memory of a goldfish. Every time you send a prompt, it's a totally blank slate. But agents, they require statefulness. They absolutely need the capacity to retain and recall context over time. To pull this off, they use two completely distinct systems. On one hand, you have short-term session memory. This keeps track of the active run, current tool calls, data just fetched, and the exact reasoning pathways the agent just took. But on the other hand, we have persistent long-term memory. This is usually stored externally using these things called semantic vector embeddings, and this is the magic piece. This is what allows an agent to actually learn across entirely different sessions and build a persistent, growing knowledge base over time.
Let's look at part 4, action and tool use. These are the hands.
So, to actually accomplish all these heavily planned tasks, agents have to interact with the outside world, right? They need hands. They can invoke built-in functions, stuff like browsing the live web for real-time data, running heavy mathematical calculations, or literally generating and executing code locally. But it doesn't stop there. They can also make external API calls to access way more advanced third-party services. And crucially, all of this tool invocation is model-driven via a technique called function calling. Basically, the agent's own internal logic dictates exactly which tool it needs to use and exactly when to fire it off. But because these agents are reaching out to so many different external tools, we desperately need some ground rules. We need structure. Enter the Model Context Protocol, or MCP. It's this critical standardized protocol that defines exactly how an agent, which acts as the MCP client,
connects securely to an external tool, the MCP server. Think of it like a universal adapter. By creating this totally standardized interface, MCP allows agents to dynamically and securely plug into an entire ecosystem of tools, all without developers needing to write custom one-off code for every single integration. It is a real game changer.
Finally, Part 5, the security reality. Let's talk about emerging agentic threats. So, while all these capabilities we just talked about are absolutely incredible, I have to be real with you. They introduce a completely new and frankly terrifying landscape of security risks. When we do threat modeling, like through the OWASP Agentic AI security initiative shown here, it forces us to look at the whole system from the perspective of an attacker. And this brilliantly illustrates the catch-22 of it all. The very things that make these agents so powerful, their autonomous reasoning, their deep memory vaults, their tool-using hands, those are the exact attack surfaces that malicious actors are going to target for sure. Let's look at how these core capabilities can actually be turned against us.
Remember that vault we talked about? Well, if an agent relies heavily on its memory to make future decisions, what happens if someone manages to corrupt that memory? Attackers can totally exploit short-term context limitations to trick an agent into repeating sensitive operations. But worse, so much worse, they can trigger what's called memory poisoning. This is where they inject completely false, malicious information into the agent's persistent long-term memory. If a hacker successfully poisons those semantic vector embeddings we talked about earlier, they essentially corrupt the agent's entire worldview across all future sessions. It completely derails the AI's logic, and it can easily lead to massive data exposure.
And what about the hands? Remember that MCP standard we just covered? As agents increasingly start using protocols like MCP, or even agent-to-agent communication to team up and share tools, they are weaving this vast, complicated new web of trust. The problem is, if the protocol specifications are loosely enforced, or if they don't have super strict identity binding, attackers can just swoop in and abuse these commands. They can easily manipulate server responses or inject fake context to totally hijack the agent's behavior. We're talking about unintended execution of dangerous tools, severe data leakage, or even irreversible system actions, completely bypassing all the guardrails we thought we put in place.
So as we wrap up this explainer, I want to leave you all with a pretty critical question to chew on. When an AI system can autonomously formulate its own step-by-step plans, build a persistent memory that lasts for months, and independently invoke tools to take real action in the physical and digital world, who is ultimately in control? The leap to agentic AI is an undeniable, incredible technological achievement, but mastering the mechanics of the brain, the vault, and the hands means we urgently, desperately need robust security paradigms to match it. Thank you so much for joining me on this deep dive today, and keep questioning the technology that's shaping our world.